For lesson 4, we'll be talking about multiplying fractions. And I want to start out with the main rule of multiplication. So just like we had that rule for addition, this is our rule for multiplication. You can multiply anything by anything. What does that mean? Well, exactly what it says. You don't have to make sure things are the same, and you don't have to make changes most of the time. You can just go ahead and multiply, okay? For example, 0.5 times 6. They don't really look exactly the same, and I don't have to line anything up. You just stack it all to the right. You just go ahead and multiply. So that's going to be 30, and then we're going to get 3 here. And remember, count your decimal places. We'll talk about this again in the next unit. Count your decimal places, so just one place. So this is just 3. This basically means half of 6. And then when we do number 2, multiply anything by anything. So 2 times 4 would be 8. And then these letters actually just stay as they are. A times B times C times D. Okay? Here's the rules. Multiplying fractions. Simplify first. You don't have to, but I highly recommend this step. Okay? So what you want to do is use factoring and the commutative law. What I mean by that is that you can change the order of things when you're multiplying. So like 5 times 6, for example, is the same as 6 times 5. That's what the commutative law means, okay? So then your next step will be just to multiply the numerators and then multiply the denominators. So really, this step 1 doesn't even really have to happen, but typically you're supposed to simplify. So literally, when you multiply fractions, it's just multiply the tops, multiply the bottoms. You can multiply anything by anything, okay? So I'm going to show you how to simplify first. This is something that you probably haven't thought about before, but it's like a cool math trick, okay? So 5/9 times 9/11. Notice that there's a 9 on the top and a 9 on the bottom. If we use the commutative property here, we can rewrite this where we switch these. So instead of 5/9, now it's going to say 9/9 times 5/11. Why is that allowed? Well, we're just multiplying these two, so it doesn't matter what order they're in. But now we see something super cool here. This is just a 1. So this is literally 1 times 5/11, or 5/11. Put it over here. And that's your final answer. Okay, so let's try that one more time on number 4. See how there's a 4 on the bottom and a 4 on the top? Go ahead and switch them. So switch these two. Now we have 4/4 times 3/5. But 4/4 is just 1. So this is 1 times 3/5, or just 3/5. If you don't simplify first, you'll end up having to simplify at the end, which is fine, but I find that this way is a little bit faster and a little bit easier because you don't have to multiply numbers that are so big. And when we get to the later examples, you'll see what I mean. All right, here, I see these two numbers that share factors, the 3 and the 9. So I'm going to switch this, and then I'm going to think about what exactly this means. So now it's going to say 2/5 times 3/9. If at this point you know what 3/9 is equal to, that's really quick. But I just want to look at it for a second. So I know that a 3 and a 9 both share a factor of 3. So what I'm actually going to do here is just simplify this by 3. So now it's going to say 2/5 times 3 divided by 3 is 1, 9 divided by 3 is 3. So this is much smaller numbers. 2 times 1 is 2, 5 times 3 is 15, and it's simplified. Okay, number 6, same thing. I don't see a match here, so I'm not going to use those. But I do see a match with the 9 and the 27. So I'm going to switch them. So now it's going to say 9 over 27 times 7 over 10. Remember, we're switching because of the commutative law here, meaning you can change the order of multiplication. So now I can say 9 over 27. What does that simplify to? Well, let me write a little note here. Actually, 9 goes into both of these. So we can divide them both by 9. So 9 divided by 9 is 1. 27 divided by 9 is 3. And now we can multiply by the other fraction. And we won't have to simplify because we already did. 1 times 7, 3 times 10. And we're done. Okay? This next one has bigger numbers, all right? So when I see this immediately, I'm like, okay, it would be nice if I could simplify first, right? So let me see. 10 and 3 don't share any factors, but 12 and 2. So let's try to switch it. So now we'll have 2 twelfths times 10 thirds. So when we do this, we have to simplify the 2 twelfths. So I'm thinking, let's try dividing by 2. So just cut those both in half. So we've got 1/6 times 10 thirds. Okay, so that's 1 times 10, 6 times 3. And now we have an answer. So at this point, we're still not quite simplified. And the reason why is because we still had a match right here with the 6 and the 10 where we could have simplified by 2. So I'm going to do that right now at the end. I'm just going to write divide by 2, meaning just to cut the numbers in half. So you're going to get 5 and then 18 divided by 2, 9ths. Okay, last one. I am not interested in doing 24 times 12. I don't want to write that out. So I'm going to use my trick. And actually in this one, if you look, this could be simplified and so could this. They both share at least a factor of 2, but I think I actually see more than that. So with the 4 over 24, that could become actually divided by 4. So that could become 1/6. And then the 8 twelfths, I think that also shares a 4. So we can do divide by 4, and we get, that doesn't look like a 1. And then we get 2 thirds. So now our new math problem is 1/6 times 2 thirds, or 2 over 18. Is it simplified? Nope. So we got to go one more time. These are both even, which means we can cut them by 2. And if we do that, we'll just get 1/9. Last up, we have a word problem, okay? And I have our graphic organizer here again. So here's the word problem. Mr. Farnach is reorganizing his bookshelves in his classroom. He needs 3/4 inches of tape. So I'm going to circle that and underline the keywords for each of the 14 labels on the shelves. How many inches of tape does he need in all? All right, let's take our annotations, so our circled numbers and our underlined words, and put them into the organizer. So what we know 3/4, and checking back my label says inches of tape. And we know there's 14 labels. And I missed this word here, each. It says 3/4 inches of tape for each of the labels. So I'm going to add that in, 3/4 inches of tape for each label. And now the question is to find the total number of inches of tape. All right, so this keyword for this problem is this word each. And sometimes each means to multiply and sometimes it means to divide. In this case, we have 3/4 inches of tape for each label, meaning for one label. But how many labels do we need? Well, we wrote that here. We need 14. So if we have 3/4 for one, but we need to turn it into 14 of those, that's going to be multiplying. Okay, and for this, we actually have to recall a rule. When you try to multiply a fraction by a whole number, you just put a 1 under it, because 14 over 1 is still 14. But now it looks like a fraction. All right. Can we simplify first? I think we can. If you look at your 4 and your 14, those are both even numbers, meaning 2, 4, 6, 8, blah, blah, blah. I'd say 14. So I am going to go ahead and I'm going to switch these. This is just a way to simplify. This is nothing fancy or new. You don't technically have to do it. Okay, so I'm going to try 2. So I'm going to cut these both in half. So what that means is 7 over 2 times 3 over 1, which would be 7 times 3, 2 times 1. And now it looks kind of funny because it's an improper fraction, so I'm going to try to make it into a mixed number. So I know 2 would go into 20 10 times, but that would mean that there's 1 left over. So 10.5. And then over here in my final answer box, it was 10.5 what? Inches. That is terrible. 10.5 inches of tape. And there you have it.